This is Shreyas here, and today is session number 2 on surface tension and surface potential energy. We all must have seen how drops of water become almost spherical when left on a surface, or if you have seen some space videos, you would have seen the blobs of water. And if you have not wondered why the drops are spherical, then I think you should start wondering now. Why are they spherical? Why does the liquid surface behave very weirdly? How are bubbles formed? What is the pressure inside the bubble? Is the pressure same as the pressure outside? What is that thing or that driving force which keeps a bubble from bursting? And how can some insects walk on water, or how can pieces of metal float in water in spite of being denser than water? We all have seen in buoyancy that if the density of a solid is less than the density of liquid, only then it can float. But this insect out here, a funny looking creature, looks like it's wiping its hands. Maybe it's sanitizing its hands. At least it looks to me like that, and it's wiping it. Look at it, how coolly it is wiping off its hands. And even look at this paper clip, it's made of steel, it's not sinking, and the reason for that is nothing but surface tension. So let's learn all about surface tension with me, Shreyas, your master teacher for physics, going live on this very own channel of yours, JEE Enthuse. So welcome everyone. Hello Ashish. Hello Anish, hello VK, hello Jatin, hello Ranjit, hello Kirito, Fida, Aarti, 17S, and so many others, Jumna, Uncharted, Stravanan. Welcome aboard everyone. Welcome. Now, in case you are new to this channel, JEE Enthuse is a very unique channel because we prepare you not just for the engineering entrance tests like JEE, but all the other tests for so many other colleges like BITSAT, be it CET, and even we are going to help you with your board preparation. We are going to conduct a lot of sessions which will help you provide strategy, tips, tricks to crack these examinations, and also KVPY. And this is Shreyas here, and I have been teaching for almost over a decade, and I have been coaching, training kids so that they do well in their examinations. And my passion is teaching, and I love physics, that's why I'm here. And you are going to see that the way in which I teach is quite different, and you are going to see it if you follow me regularly. So do follow this channel first of all in case you are a new user, and you can also get in touch with me and see all the cool amazing videos that I put up. I hope you have seen the video which I put up on Instagram, and you know where to follow me. That's here, Shreyas_Vedantu. That's my Instagram handle. I have put up some really cool videos. In fact, I have told how to propel a boat without using a motor today, and the answer for that video will also come in today's session. So welcome everyone. Hello Ankit, hello Sneha, hello Uma, welcome, hello Bhakti, hello everyone. All right, VK channel. So let's get going, and before I forget, do not forget to hit the subscribe button. And I hope you have already smashed that like button out there. So go ahead, smash that like button if you have not done it yet, because that's the fees of today's session, guys. Your free like is going to be my source of energy and also the fees for watching today's session. So go ahead, subscribe in case you have not done it yet, and also go hit the like button right now. All right. Hello, welcome Shreya. Welcome Holly. All right. So a small change in the schedule. Let me tell you, yesterday we have done viscosity and drag force. Today we are going to do surface tension and energy. Like I said, I'm going to split the surface tension chapter into 2 parts. And tomorrow at 7 p.m. we are going to do bubbles and capillary effect, all about it. And on Thursday, keep in mind, 2 o'clock, it's going to be elasticity and solids. Stress, strain, curve, potential energy, all those things. We are going to do it at 2 p.m. It's not 7 p.m. Be careful. And same day, on Thursday only, there is going to be live streaming event. Yes, the education minister is going to answer all your queries on boards, which is going to be conducted next year, and we are going to do live analysis as he speaks, so you don't have to switch on the TV separately and listen to our lecture separately. It's a waste of time. We are going to do both at once. I'm going to give you my analysis and we are going to decode that session. It's a live streaming session. On this screen, you're going to see him answer all the questions and we'll be commenting. I'll be answering all your doubts, etc. on the chat. So it's a very important session. Your parents, your neighbors, your relatives, everybody can join in the live stream event. All right. And on Friday, it's going to be a premiere. It's not going to be a live session. Capacitors, because a lot of you are asking when will the capacitor session be. I was originally planning it to keep it next week, but I thought then it would be too late. So I'll be recording that session and I'll be posting it on Friday. So that's the premiere of capacitors, session 3. That's the last session of capacitors. So do watch it on Friday. All right. I hope this is clear. Everyone, are you geared up now to start the session? Let me know if your Josh is high and if you understood everything, and I hope you're going to be there everywhere. And do not forget, guys, same Thursday, it's going to be a very busy day, let me tell you. 7:30 a.m. it's going to be your Menti quiz on fluids, viscosity and surface tension, and chemistry. Sunday you're going to have 9 p.m. the Menti quiz. All right. All right. Very good, Jumna, Bhakti, Kirito, Sneha, Fida, Simran, Uncharted, Tanmay, yo. Let's begin today's session then. So, let's talk about why liquids contract. Let's talk about why a drop of liquid is spherical in nature. So, we're going to talk about all of this. And the reason for that is one simple force called as surface tension. So, stay tuned because there are a lot of very good problems, which are going to come up on the way. So stay tuned now. Now observe the shape of this drop. It looks spherical. I get a sense that the liquid surface always wants to contract itself. Yes, look at any liquid surface. I feel that it has a tendency to contract. It wants to minimize its area. Why it wants to minimize and why does it want to contract? We are going to answer that. But I get a sense looking at all of this. You'll be like, sir, why? I'll tell you. See, first of all, understand for a given volume, if you are trying to explain why does it look spherical, the answer to that is, understand for a given volume, the least surface area is for a sphere. Think about it. If you have a given volume, just one second. Yeah, if you have a given volume like this has a lot of area, but if you make it into a sphere, this has minimum area. So this is very important rule, which I'm writing it over here. For a given volume, okay, so for a given volume, least area is for a sphere. Very important, because once you have a sphere, if you try to distort that sphere, think of it this way. You have a sphere, you try to pull that sphere and make it look like this, because the volume has to remain the same. So that's why there will be a depression somewhere else to conserve the volume. Now think what has happened. You have obviously created new areas over here, so obviously the area has increased. So that's why I can say a sphere has the least area. Now why does a liquid want least area? We are going to come to that, but I hope this is clear. Yes, Maruti, there are going to be sessions on that as well. Don't worry. Okay, so if that is clear now, then understand that in space there is no force apart from the force of surface tension, which we are going to talk about it shortly. So the surface tension is the most dominating force. So in space, what happens? You will see the water drops are almost spherical. But on Earth, if you have water in a bottle, it does not form a blob, because gravity is much stronger than the force of surface tension, and it plays a bigger role than surface tension. unless and until you have drops of water which are very tiny mini, and then the forces of surface tension becomes very dominating in this case. Otherwise, you will see generally for most of the scenarios, gravity is the dominating force. So let's talk about the surface tension force now. So what exactly is happening at the molecular level? So first let me talk about cohesive and adhesive forces. So what is cohesive? Cohesive force means the forces between similar kind of molecules. Say for example, there is water molecule and other water molecule. So both these molecules exert some kind of force between them. That is called as a cohesive force. Adhesive force is forces between different kind of molecules. So if there are different kind of molecules, the forces that they exert between them, like water and mercury, or water and oil, or oil and mercury, all these are called as adhesive forces. Sometimes cohesive forces are more, sometimes adhesive forces are more. Depends. And it completely depends on the molecules, guys, which will attract each other, which will repel each other, etc., etc. For now, we just need to know that there are two kinds of forces. One is cohesive, one is adhesive force. Now, imagine this. If I tell you that there is a molecule, okay? So imagine there is a molecule over here and there is another molecule over here. If they form a bond, is it good for them? Is it going to release energy? Yes. So whenever molecules form intermolecular weak bonds with each other, it's good for them. They release some energy. So whenever a bond is formed, the potential energy of the system decreases. Now, if this same molecule forms another bond with, let's say, another molecule, so these are all cohesive bonds, then the potential energy will decrease further because it is forming one more bond. Now, if it forms another bond with some other molecule over here, alright, the potential energy will further decrease. So every time it forms a bond, you will see that the potential energy keeps decreasing. And what have we seen before? If some system has very high potential energy, it is very sad. And whenever the system has low potential energy, then it is going to be very happy. So understand, whenever a molecule forms intermolecular bonds with other molecules, cohesive bonds, molecules of the same kind, alright? So you will see that every bond will release some energy and the system's energy keeps decreasing. The potential energy keeps decreasing, which will make it more and more happy. It's just like you meeting many people. You are having one friend, you will be happy. You have two friends, you will be more happy. You have three friends, you will be more happy. You want to have a lot of people around you, you want to have a lot of friends, so you will become more and more happy the more the number of bonds you have. It makes the molecule more satisfied, it makes it more happy. I hope it is clear. Alright, now if this is understood, guys, so I can just write it over here. More the bonds, lesser the potential energy, and I can say the molecule is more stable. So I can say it is going to become more stable. So that is the logic of this. Okay, I hope you have written it down. Now, what happens in case of a liquid which is kept in a container? Think about a molecule deep inside it. Molecule which is deep inside it. In fact, I am going to now categorize two kinds of molecules. Molecules which are deep inside the liquid, which are away from the gaseous state. So these kind of molecules which are deep inside are called as bulk molecules. They are called as bulk molecules, and basically they are deep inside the surface. Now this molecule is surrounded by like molecules around it, and it will form bonds with this guy, this guy, this guy, this guy, this guy, and in fact even in 3D, here, there, here, everywhere. But now think about the molecule over here. Bechara molecule, poor molecule, it can only form bonds with the molecules which are there below it and towards this lower side. It lacks molecules on the upper side. So think about it. this molecule is going to be really happy, guys. This molecule is definitely going to be very happy. In fact, even these molecules are going to be really, really happy because these molecules have a lot of people around them. Each molecule has a lot of people around them. But this molecule is definitely going to be very sad. These are sad molecules. Look at their sad faces. In fact, if they look at them, if they are given a chance, these molecules would like to be here because they want more people around them. I hope this is clear. Now, understand, if this is the scenario, now given a chance, do you want to be a bulk molecule or do you want to be a molecule on the surface? These are called as surface molecules. The answer to this will be obviously I don't want to be a surface molecule. I want to be a molecule inside the bulk. So what will happen? There will be a tough competition between all the surface molecules to go inside, and they want to reduce the surface area. That's the reason why any liquid surface always wants to minimize its surface area. So because of this, I can say the potential energy on the surface is obviously more than the potential energy inside the bulk. So I can say the surface molecules are less stable and the bulk molecules are definitely more stable. And because of this, I can say that there is a tendency to reduce the surface area. So there is a tendency to reduce the surface area, and I can say because of which the surface behaves like a membrane. It behaves like a membrane. Now membrane means a rubber sheet. So a rubber sheet is nothing but like a thin membrane. So what happens, or if you have seen a trampoline, if you press a trampoline, what happens? It comes back. If you pull a trampoline, it comes back. It's like a stretched membrane. I get the notion that as if these molecules are forming a stretched membrane. Why? Because the moment you try to press a surface and there is a depression formed, imagine the moment there is a depression formed, the surface area increases. The moment surface area increases, the molecules are not going to like it, so they are going to push you back, and that's why they try to minimize the area. So that's the reason why I'm saying that the surface of a liquid feels as if it is like a membrane which is stretched, and that's the property of surface tension. I hope this is very, very clear. Bulk modulus is completely different. I hope this is very, very clear, guys. Okay, so the surface behaves like a membrane, and this property is basically telling us how these molecules behave in a liquid, and that's the reason why surface tension occurs. All right, very good. No, Shalini, I don't know Tamil. All right, now if this much is understood, we can very well now explain why this was floating, why that insect was floating. Look at that liquid surface, guys. It feels as if it is a rubber sheet and you have dropped that insect on that rubber sheet. What is happening? There is a small depression which is created. I don't know whether you can see it where the legs are. So there is a small depression which is created, because of which, the liquid surface will try to contract itself and it will push that insect up or those metallic pieces up. So understand, surface tension has got role over there. Okay, now let's talk about some more things. Understand the molecules on the top which are near the surface. These are the molecules with high potential energy. They are responsible, all right, I can say these molecules which are having high potential energy, they are responsible for the surface tension. The molecules inside the bulk which have low potential energy, they are not going to take part in surface tension. All right, they are not going to take part in surface tension. Now, what is the direction of the force of this surface tension? Because we are talking about surface tension so much, this tendency to contract. What is the direction in which this surface tension pulls? You are going to see it shortly. In fact, this force is going to lie in the plane of that surface. So imagine there are a lot of molecules here. Each molecule is trying to contract its surface. Basically, the surface is trying to reduce. So all the molecules are trying to come close to each other and they want to go deep inside the bulk. So the surface tries to contract. Visualize this in 3D. Imagine a layer of surface molecules and so many layers of bulk molecules. This surface would try to contract from every angle that you can think of. So understand that the force of surface tension will lie in that plane which you can think in 3D. So it will try to contract itself inwards. Understand that. Okay, I hope this is clear. Now, in fact, this is the reason why water droplets are formed. Because if you talk about a molecule on the top of a droplet, all right, something like over here, these are nothing but the surface molecules. Now, this is very interesting to see. These are nothing but surface molecules. The molecule deep inside, they are nothing but bulk molecules. Now you might be like, sir, obviously, this molecule is definitely going to be unhappy because it's on the surface. These bulk molecules are definitely going to be happy because they are deep inside. So they are unhappy, they are happy. So why can't we put more and more molecules inside? Because if I put more and more molecules inside, then this area will reduce. Think about it, this area will reduce. So this will be much better because the area is going to be less. If I spread a drop, imagine if I spread a drop, all right, the area will increase. But if I make that drop smaller so that the area minimizes, that will be much better because the area is going to be less. But the problem is that the moment you do that, the center of mass rises. Yes, the center of mass will basically rise. And because of that, the gravitational potential energy will increase. You try to reduce the surface potential energy by minimizing the area, but the other form of energy, which is gravitational potential energy, will increase. And there will be a point of time when you will see there is no more advantage of reducing the surface because you are ending up increasing the gravitational potential energy. So that's the reason why a drop on a surface will not completely contract and form a sphere. So you will never see this. You will never see this, a water drop forming like this, because this will definitely have much more potential energy than this. This will have much more potential energy than this. Then you will be like, sir, then we can reduce the gravitational potential energy a lot. We can make the center of mass go down as close as possible to the surface. Yes, very good idea. If you try to bring that center of mass really down, then what will happen? The water will spread a lot. All right, water will spread a lot, and then the surface of the liquid will increase. Now, the moment surface of the liquid will increase, the surface potential energy, the potential energy on that surface will increase because the molecules, remember, on the surface are very sad. So you are going to make a lot of people unhappy by putting them on the surface. So it finds, like a compromise on both, and it takes a shape where both the energies are at its minimum state. I hope this is clear. I hope this is clear. I hope everyone is understanding this, why the water does not spread a lot and why doesn't water form a drop and form something like this. So it forms something in intermediate state. Yes, there are some kids making noise, just ignore them, guys. We can't do anything. And I'm pretty sure even when you are kids, you would have been making some noises, all right? Okay, great. Now, let's talk about the force of surface tension. What is the direction? What is the magnitude? Pay attention now. Just imagine there is some liquid filled in a container. How many surfaces are there? Now most often people say, sir, there is one flat circular surface on the top, there is a curved surface, and there is a flat bottom surface. Yes, you are right. There are three surfaces of the liquid, one on the top, a curved, and one at the bottom. But whenever I talk about a surface of a liquid in this chapter, I am referring to only that surface which is exposed to air. Only that surface which is exposed to air, not the ones which are facing the solids or any other liquid. Understand that. So be very careful here. Whenever I have spoken about surface tension forces, those forces were only at the surfaces which are actually exposed. Be careful. Okay. Now, once this is clear, I'll just mention it. This is basically exposed surface. This is basically exposed surface. These ones over here, they are hidden surfaces. They are called hidden surfaces. We will be dealing about these hidden surfaces in the next session, because these hidden surfaces are nothing but going to probably make bonds with the molecules of the container. Alright, there are molecules of the container over here, so they might make bonds over there, they might act very differently. So we are going to talk about them later on, but now we are only talking about those exposed surfaces. Alright, so understand this. Now, on that exposed surface, the surface will try to contract from every side. You can think about it, it's trying to contract. So if you just look at that surface which is exposed on the top, this is that free surface. Alright, so this is the surface of that fluid. That force will act everywhere inside, radially inside. If you take this point, it will try to pull everything from every side like this. If you take this point, it will try to pull everything from every other side towards it. Visualize this in 3D. Now, if that's the scenario, if I take an imaginary line, alright, this is just an imaginary, alright, this is just nothing but an imaginary line of length L, then think about it, that line, if you divide it into two parts, or if that line divides this surface into two parts, this side of the molecules will be pulled this way by the molecules on this side, and the molecules on this side will be pulled by the molecules on the other side like this. Think about it. Newton's third law. So what are these black forces? These are the forces acting on the molecules on this side like this by the molecules here, like a tug of war, and the molecules over here are being pulled here like this. Because remember, it's a stretched sheet. How does tension act? Tension acts both ways. Same way, tension is acting no matter where you draw that line, it will always be pulling on both sides. So this is also the force F, and this is also the force F. Now if you take the line to be longer, this force will also increase. Why will that force increase? Because there will be more people in your tug of war competition. So more the length of this imaginary line, more is the value of this force. Hence, basically, this force is proportional to the length, and that constant of proportionality is called S, and that is nothing but the surface tension of the liquid. So please understand, the surface tension of the liquid is not in Newton, it is in newtons per meter. It's a force per meter which is called as the surface tension. It depends completely on the liquid. For oil it will be different, for water it will be different, for a glycerine it could be different. So these values will be given to you. You don't have to sit and by heart, just like coefficient of viscosity or coefficient of friction. So don't worry about it. S will be given to you. But S tells you how much force is there per meter of imaginary line which is drawn on the free surface of a fluid. That's all it is said. Yes, L is the length, obviously. L is the length. I just mentioned it over here. And this force, please understand, it only acts it only acts along the free surface, and this is the first point. And second thing, it is perpendicular to the line, this is imaginary line drawn. It acts perpendicular to the imaginary line drawn, and it acts both ways. It depends. If you are taking this part, it will be pulling this way. If you take this part, it will be pulling it that way. I hope this is clear. Is that understood, everyone? What reply? L is length. Yalamla, which reply I did not give? Technical, probably you can put in a message or put in a comment. I'll definitely reply to you. All right, how to revise. Brajesh, I remember you. Yes, please join in. Instagram, don't worry, Alamla, I will reply. Probably I will always take some time to reply because there are so many messages that I get. Don't expect that I will reply within 5 minutes only. Don't worry, I'll reply to you. Okay. Okay. Subha, very, very happy birthday to you. Many, many happy returns of the day. God bless you and hope you do really, really well in life. Very, very good. Happy, happy birthday. All right. So, now that if you have understood all of this, let's take up some problems. These are very important problems because people never understand these problems. I have seen. They fail to visualize, but today I'm going to make you visualize a lot of things. Now, what happens if I take a wire which is bent in the form of a C and there is a rod which can slide left and right? Look at this. This is like a wire and there is a rod which can slide left or right, and I dip this entire setup in a film, in a soapy solution, so that there is a thin film which is formed over here. I hope you can see this film. You can see this film. So what do you think this rod will try to do? Will it try to move? And if it tries to move, where do you think it will try to move? Towards your left or towards your right? What do you think, guys? What do you think? Will it move? And if it moves, where do you think it will move? And why do you think it will try to move? The film is here. This is a soapy film. There is a rod. That rod can slide left or right depending on the forces acting on it. What do you think will happen? Hello Shreyas, join in. A lot of you are saying right, a lot of you are saying left. It's a mixed reaction. So don't worry, VK channel, just join in. Guys, the answer is towards the left. Look at the film. This is a film which has some area. I hope you can visualize it. What will the film's molecule try to do? They will try to minimize their area. So they will try to contract from everywhere. Now it cannot pull this rod, it cannot pull this rod, it cannot pull this rod, but at least it can pull this rod. Now the moment it pulls this rod, yes, the area reduces because those molecules which are there on the surface, they will start going inside the bulk. I hope you understand this film is not one surface. There are many layers of molecules. You might assume that the film is of almost some few millimeters thickness, but even in that few millimeters of thickness, there are trillions of molecules. Yes, millions and trillions of molecules. So what will happen, guys? Understand, a lot of molecules are going to come deep inside those layers. And that's the reason why it will be pulled towards the left. I hope this is clear. Yeah, correct Sneha. This became like a march past. Some people saying left, some people saying right. So now let's solve the question. Very important question, but people don't understand. Yeah, there is a wire bent in the form of C. There is a film over here. So there is a force because of the surface tension which pulls the rod towards the left side. Now if you have understood this, let's try to figure out what is the value of the force. Now, I know what many people say, sir, length is L, force is surface tension into L, hence that is the answer. That's not the correct way of looking at it. Let's not do that way. Understand what is exactly happening. If I look at that film, like I just told you, it's not one layer. Actually, there are many molecular layers. You cannot see it, but it is there if you see it under the microscope, something like this. This film, if you think about it, there are many layers inside it. You can see that this is the layer on the front, and the last one is the one which is behind. So think about it. How many surfaces does this film have? If I talk about this film, thin film, neglect that boundary. How many surfaces does this film have? The answer to that, free surfaces, understand, free surfaces. How many surfaces does this free surfaces does this film have? The answer to that will be how much? Yes, Ranjite, very good. No, Aishwarya, think again. It will be 2. Reason for that, this is one surface. This is one surface and the other one is behind. This is the other surface. Understand that. Rest, all other things over here, they are inside the bulk. Understand, these layers are within the bulk. I hope this is clear. No, they are not infinite surfaces. Free exposed surfaces, there are only 2 surfaces. One in the front and one behind, and anything in between them, they are bulk molecules. See if you guys are able to visualize this. I hope you guys are able to visualize this. Now, if you guys are able to visualize this part, then think this rod which is there, that rod which is there, it will be probably something like this. This is the extended version of that. Think of this rod. All right. Think of it this way actually. This rod is like this. Okay. This is that rod in 3D. Now think of, oh, once again. Not like this. I had to draw it this way. Yeah. This is that rod. Okay, so the rod goes like that, guys. This is that rod. Visualize it that way. So this is the layer which is in front. This is that layer which is in front. This is that layer which is behind you. Now think about it. Force of surface tension can only act on the free surface. So there will be forces on the front side here and on the back side like this. Think about it. The between layers, they will never apply any force. So there will be 2 forces. Think about it. One force on this side like this towards your left, and all the layers behind, the more extreme behind layer, that layer will be pulling that rod towards the left side. So I hope you are able to visualize that there will be forces from 2 sides, one from the front side, one from the side behind it. Yes. So because of which this force is actually S into L, but 2 times, where L is the length of the rod and S is the surface tension of the fluid. That is something which you should understand. So the moment you understand why that 2 has come, that's it. We are done about this problem. Understood, everyone? I hope this is clear why 2SL has come. And if you want to look at it still the other way, look at it. This was that rod. Okay, the force of surface tension is pulling it towards the left side. If you see it from here, from below, this is what you're going to see. This is what you're going to see. This is that layer, that thin layer, guys, the thin layer. This is from below. If you see it like this, this is that wire. This is the cross section of that wire, and you can clearly see that there will be one force from here and one force from here, which will pull that rod like this. Yes, correct. Yes, so there are 2 forces, each one of them is SL, SL. So that's why the net force is 2SL. In fact, this same apparatus can be tilted slightly like this. Slightly like this. You can have that rod here, and then you can have that film formed over here. And what you can do, guys, you can suspend some weight like this over here of mass M, and this mg force will be balanced by how much force? 2SL. From this, in fact, you can calculate the surface tension of the liquid. The weight which will just balance that rod This M includes the rod's mass, the mass which is suspended, everything. So the total weight below should be balanced by 2SL. From that we can calculate the surface tension. All right. Yes, Kirito, correct. Number of surfaces exposed. Now how about solving this problem? A wire is kept at the interface of two liquids. One side the liquid has surface tension S, other side it has 3S. First of all, which side do you think the rod will be pulled? Come on, answer this. Answer this, guys. Which side do you think the rod will be pulled? Come on. Yes, very good, Uncharted. Very good. Yes, it will be pulled towards the right side. Why? Because this liquid has more surface tension than this liquid. So this liquid has more tendency to pull. Excellent. Now, this is what exactly happens when you pour, let's say this is soap. Okay, when you pour soap and let's say here there is water. Now, when you pour soap over water, what happens is soap gets pulled from everywhere. Soap gets pulled from everywhere. Even water gets pulled, but soap actually expands. So soap actually ends up expanding. Reason for that is because water has more surface tension than soap. Because water is pulling this boundary which is there is being pulled by water. So water has more surface tension. So the surface tension of water is more than surface tension of soap. So soap will expand. I hope this is clear. Now that's the reason why in the video which I have posted on Instagram, if you have not seen it yet, please watch it. So what happens is the moment you pour some soapy liquid over here, that soap will immediately come out. It will immediately come out like this. It will try to spread everywhere, and that's the reason why you will see the boat will propel forward. So that's the thrust force the boat is getting. The soapy liquid is trying to gush its way through this tiny narrow part, and that's why the boat moves ahead. I hope this is clear. Yes, we are going to come to acceleration velocity. Hold on, Saurav, but I hope you understood this concept. Yes, you can cut it in other shape, but I found that this shape was very efficient, so that's why I cut it in that way. Okay, I hope this is clear, guys, everyone. So that explains that Instagram video. Excellent. Very good, VK. Very good, Princey. Very good. Now, since we know that the force from this side, the right side, is going to be 3S into L but into 2. 3S is the surface tension, L is the length, into 2 because there are two surfaces, do not forget. One in the front, one behind. I cannot see that, but it's there. And the force on this side will be S into L, again into 2 because there are two surfaces. So what should be the net force? Net force should be towards that side. It will be 3SL, which is nothing but 6SL. 6SL minus 2SL, which is going to be 4SL. That's the net force, and we know that net force is mass into acceleration. That's Newton's law. So therefore acceleration will be 4SL by m. So we have found out the acceleration. As a function of time, the best part, it's a constant value. That means there is no time in the relationship. So it clearly tells me it is constant. It's clearly seen there is no time over here. Now, once I know the acceleration, we can also find the velocity using kinematic equation. V is u plus at. Therefore, V will be equal to 4SL into time. All right, 4SL into time by m. So that's the formula for velocity. I got. Don't by heart it. This was just a numerical problem which I told you how to solve. Alright, so it had a lot of variables, but this is the solution for this. Very interesting problem. This is the velocity. I hope you guys are slowly getting the hang of surface tension. Are you guys getting the hang of surface tension? Let me know, guys, and if you are understanding it, please hit the like button below. If you have not done it yet, come on, go ahead and do that. Go hit that like button. Very good, Aishwarya. Very good, VK channel. Very good, Jumna. Come on, everyone in the chat box. I will only know if you guys are present over here only when you put up your comments and your chats in the chat box. Very good, Sneha. Very good, Science Priya. Very good, Shreya. Very good, Krito. Excellent. Come on. Let's get going now to the next thing. But before that, let me tell you guys about the crash course for all the 12th and the dropper students. So if you are in 12th or if you are a dropper student and if you want to know what's the best way to study, guys, if you want somebody to always be, guiding you, always be behind you so that you can achieve certain targets in short term and eventually your long term target, which is, cracking the JEE Mains examination. So if you want that, then the crash course is very important. If you are not having any guidance, or if you feel that you have wasted the last 2 years, or for some reason your coaching was not good. So there are going to be 120 live sessions with 10 full and 10 part test series, along with, there are going to be special sessions for tips and tricks by our experts. And the teachers who teach over here, I know them personally, they are very good. And also you will have doubt solving after the class, right from morning till the night. And even in the class, we have a 2-teacher model. So there is always a master teacher like me, and then you have class teachers who solve all your queries. So it's a very beautiful experience. You should try it out. A lot of quizzes, hotspot polls, and lot of fun apart from the studies that you do. So you should definitely try it out, is what I say, because the course price is hardly 10,000 and in the offer it's only for 8,000. So you get 20% off when you use this coupon code of SHCC. And if you want to know more details about it, please go ahead, check the description box. There will be a link for joining the crash course. Just first look at it, read all the details, see everything, and it starts every Monday, so you don't have to worry, you're not going to miss out on anything. All right, so do that. Okay, so a lot of people are planning a party. Yaar, come on, include me also. Come on, include me also. Abhijit, Marathi मध्ये पण मी बोलू शकतो, but I will not talk too much Marathi here because it's an English channel. All right. Okay. So very good, Simran. If you are already a part of crash course, here's the next question coming up on your screen. There is a loop of thread which is in the plane of a soapy liquid, soapy film. What happens if the film inside the loop is punctured? If I puncture this using a pin, what do you think will happen to the loop? Options are on your screen. What do you guys think will happen? Sora, I'll give you party when you all clear the entrance test and you come out with your, your final counseling slip saying that, sir, this is my college, sir, this is my branch, sir, this is my, state, this is where I'm going. So when you do that, that's when I'm going to give you guys party for sure. Guys, come down anytime to Bangalore and you can definitely catch up with me. Thank you, Science Priya, for the virtual cake. Thank you, Sneha, for the virtual cake. Thank you, Princey. Alright, so a lot of you are saying option A, the thread expands, and that's correct, guys. Because what happens when you puncture this part inside, this remaining liquid or the soapy film which is there, understand, this remaining soapy film which is there over here, that is going to contract itself. It wants to reduce its area, this part, correct? This soapy film is there. So that soapy film is going to pull it from every side like this. Earlier what was there? There was soap on both sides. So this tug of war was not one, or it was a draw, or it was a tie. But the moment the film inside disappeared because you punctured it, only these red forces are there, and that's it. It's going to expand it and you will see a beautiful circle being formed. Why will you see a circle? Because of symmetry. So everywhere you will see eventually it will pull itself and it can no longer expand, and that's it when it forms a circle. Alright, very good, very good. Now, yes, Kirito, why not? We'll definitely play table tennis whenever we meet, for sure, for sure. Yes, you can try it out at home, Ranjit. In fact, you can try out the boat experiment as well. Now I'm going to create a very beautiful problem on this. Very same thing. By the way, this is how it looks like. If you try it out at home, probably you can post some pictures and you can also tag me on Instagram. So Shreyas_Vedantu. So this is how it looks like when you puncture it. You can see a beautiful loop being formed. This is that film. the film is almost transparent, that's why you cannot see it. Okay, I hope it is clear. Let's go ahead. Now, a soap film is formed in a circular frame loop of thread is lying on the film. Okay, so there is basically a circular loop which is formed because the film outside is pulling it from every side. So actually, wait a minute, I don't know, the wordings of the problem look little bit weird, but the logic or the intention of the question is this: there is a loop, okay, and you break the film inside, because of which it gets pulled from every side, and then the question is to find the tension inside the loop. So find the tension, not surface tension, tension. This is that tension in Newton's laws. Remember, the thread is being pulled from every side. Okay, I'll make you visualize this. Imagine the loop is divided into particles, and think of each particle as a person, or imagine each of them is a pandu, or imagine each of them is some person out here. Now each of them is holding hands with the next person and they are playing Ringa Ringa Roses. Imagine you holding hands like this and the next person is holding hands with the next person, etc. You all try to go away, you all try to move away. Okay, why? Because the liquid is trying to pull you, it's trying to expand that circle. What do you think your hands will be in? Your hands will be obviously under tension. So that's what has been asked. Yes, so many pandus out here. Okay, now if you understood the problem, let's try and solve this question in a very, very beautiful manner. Now guys, this method is very important, very important, because you know you're going to see a lot of questions based on this in JEE Advanced and sometimes even in JEE Mains. So here is the thing. This was my loop and it was being pulled from everywhere like this. It was being pulled from everywhere like this, and I want to find out what is the force of tension which acts within the loop. So this is exactly what I want to find. Now to do that, what I'm going to do is imagine a part of a circle. Okay, so let's do this. Okay, so imagine a part of the circle. Imagine a part of the circle. Let's say this much part over here. And I'm only going to draw the free body diagram of this much part. A small element. This is a very small element, guys. I don't know whether you can see this, slightly shaded over here. Now let's say that small element subtends some small angle over there. So let's say this is radius r. There is a small angle which is subtended. So let's say each of them is nothing but d theta by 2, because remember this was nothing but a small element. So I've just taken a small element of the thread, small, very small, it subtends very small angle, and that angle is d theta, very small. Now let's think about the forces acting on it. Okay, let's think about the forces acting on it, and the forces acting on it are something like this. Observe, from one side there will be tension here, and from the other side there will be another tension pulling it like this. Think about it. The small angle has made the tension not horizontal but tilted at a very small angle. I hope you can visualize that. So each of them I'm just going to call it as the tension. Both sides will be same because of symmetry. Everywhere the tension should be same. Very important. Alright, if blue is not visible, okay. So I hope it is visible now. Okay. I hope it is visible now. Okay. So this is how the force is going to act, and at the same time there will be the force due to surface tension. The force due to surface tension which will be acting on the thread like this, whose resultant will be here. Think about it. The resultant will be up because the liquid is trying to pull it like that. I hope this is clear. Alright, I hope this is clear. Now, if this much is understood, let's try to resolve these forces because it's very important. Without resolution, you cannot solve it. So I'm just showing the horizontal lines. Now think about it. If this is d theta, if this is d theta, if this is 90 degrees, then how much is this angle? I feel even this angle should be d theta by 2. Why? Take your right hand, make sure your pointing finger and thumb are perpendicular to each other. Place your thumb against this middle line and your pointing finger in that direction of that blue dotted line. Now just tilt your hand like this. If your hand tilts by d theta by 2, even your pointing finger tilts by d theta by 2. You can see that very clearly. Just see that. I hope you can see that. So it is going to be d theta by 2. Very easy way. Now think this way. In the x direction, this tension's cos component is being balanced by this tension's another cos component over here. There is going to be another cos component like that. So they two cancel out each other. But what happens in the y direction? Think about it. That force of surface tension is being balanced by this tension's sine component, correct? So that force of surface tension is being balanced by the t sine d theta by 2 component, but there is one more tension's component here, so that's why into 2. Just let me know if you guys have understood this, if you guys have understood it. Alright, so how did I get theta symbol? I have assumed it. Alright, I have taken a small element because it's going to involve derivatives and integration maybe. So I took a small element because I cannot take the entire thing as a system. Reason why I took a small element is because if I take the complete circle as a system, then how do I find tension? Because tension is an internal force. So that's why I took a very small element. Okay, I hope Saurav and Aishwarya this question gets answered. Now, if this much is clear, what is the value of this force? This force is S into the length. Why? Because force of surface tension is S into L. Now, this length of that arc, think about it. This length of that arc. What is the length of that arc? Length of an arc is radius times the total angle subtended. Remember, this is also d theta by 2, angle bisector. So this total angle will be nothing but d theta. Length of the arc will be r into d theta. I hope this is clear. Hence, what will be that force? That force will be S into the length of the arc, which is r d theta, but into 2. Be careful. Why this 2 has come? Because there are two surfaces. Remember, one in the front and one behind. There is one surface in the front and one behind. Very, very important. I hope this is clear. Everyone, is there any doubt till here? Please ask. And this should be obviously equal to t, or rather 2t sine d theta by 2. This is what I got. Now, this 2 and this 2 will obviously get cancelled. Okay, this 2 and this 2 will get cancelled. And I have SR d theta is equal to t. Sine of a very small angle is the angle itself. That's a property you learn in mathematics, in trigonometry, or in derivatives. So this will be equal to just d theta by 2. This is called as small angle approximation. So small angle approximation says that sine of theta, when theta is small, is approximately equal to theta itself. That's a very, very important approximation. You will need it many, many times. No, the thread, understand, the thread is kept in the plane of the film. So visualize this. Visualize this. This is the thread, which is like this. Okay, and you have the film like this. So there is one force from here and another force from below. There are two forces, guys. One from the top, one from below. I hope this is clear, uncharted. I hope this is clear. Now, what will happen? d theta will go, and therefore you will get T is equal to 2 SR. Now I'll tell you what is the problem. The problem is that many places, even online and in many books, they have given just SR as the formula. They have given SR. So they have forgotten that there will be two surfaces. So this 2, why did that 2 come? That 2 came over here. Alright, this 2 came over here because there are two surfaces. But they have not taken two surfaces. That's why their answers are wrong. This is the correct answer to the problem. Please understand that. Lot of books have given SR as the answer. That's a mistake. Very, very important problem. And if this comes in JEE, it will be a very good problem. It will be a proper advanced question. Yes. Okay. So a lot of concepts, trigonometry is there, small angle approximation, choosing an element, everything, resolving forces, so many things are there in this question. So that's the answer for it. So let's get going to the next part. Okay, so we just solved that. Now let's talk about potential energy. So whenever you pull any surface and you stretch it, a lot of molecules come on the surface. So these molecules are very unhappy, unsatisfied. So I can say the surface potential energy increases. And there is a simple formula for that. And the logic behind this surface potential energy is the molecules on the surface. Remember the molecules on the surface, the sad faces, have more potential energy than the molecules in the bulk. This extra potential energy is referred to as surface potential energy. I'll give the symbol for that as U. Okay, and hypothetically speaking, if the area of that surface tends to 0, then the surface potential energy should also tend towards 0. So if it has negligible surface, then the energy should also be 0. Now, here is the thing. Yes, surface has extra potential energy as compared to the bulk. The formula for that is USA. Just remember USA, guys. U is equal to SA. That's it. That's the simple formula. It's very easy to remember. Energy on the surface, extra energy as compared to the bulk, is surface tension into the area which is exposed. Understand? That's the free surface area. That's it. Yes, Dhanush, and plus you will need previous year's questions as well. Okay. Yes, USA. That's simple formula. And you can also remember this formula, guys. U is equal to SA. That's one thing. And delta U is equal to S delta A. When will this formula be used? Whenever area is changing. So if the area changes, potential energy changes. So delta U is equal to S delta A. So this refers to the change in the area. That's all. It's one and the same thing. If you know this, you will also know this. Okay, let's do some questions, guys, on this. Let's see how many of you get this question. 8,000 identical water drops are combined to form a big drop. Then the ratio of the final surface energy to the initial surface energy of all the drops together is how much? Come on, just figure this out. 8,000 identical water drops. Come on guys, they form a bigger drop. What do you think is the ratio of the final surface energy to the initial surface energy if they come together? Come on, the total energy before and after. Sudan, welcome, join in, start solving the question. All right. Let's see, some of you are saying A. VK is saying A, Saurav saying B, Uncharted saying C. We have a lot of diversity out here. So come on. Alright, Fida is also saying C. Okay, so let me tell you, the correct answer is actually C. And let's see why it is C. Okay, so 8,000 identical water drops. Okay, so each drop, if you assume it to be R, like that you have 8,000 of them. When they form a bigger drop, what will be the new radius? Well, let's assume it to be capital R. Just use volume conservation. Think about the volume of the bigger drop. Volume of the bigger drop will be 4 by 3 pi R cube. Correct? And the volume of the smaller drop will be 4 by 3 pi small r cube. But there are 8,000 of them. Now, what if I write it like this? R cube into 8 into 1000 is equal to capital R cube. Now you know what to do. Take cube root on both sides. So it will become R into 2 into 10 is equal to R. Therefore, R is equal to 20 times small r. So you can see that R is nothing but 20 times small r. The radius has increased 20 times. Now, this is using volume conservation. Now, I'm going to erase this because I'm not going to need it. Now, think about what was the initial energy. Initial energy will be 4 pi r square. This is the area. Alright, this is the area into surface tension. This thing will give me, surface energy. This is just going to give me surface energy of one drop. Understand? U is equal to SA. That is what I'm using. But there are 8,000 like that. So that will be the initial energy. Similarly, what will be the final energy? It will be again 4 pi, but this time big R square into S. But there is only one drop like that. But I know what is R square. What is R? 20 times of R, small r. So it will be 4 pi 20 times small r square S. So this will become 4 pi r square S into 20 square. I'll just keep it over there. Now just divide both of them. So what will be UF by UI? That is the question. UF by UI. So it will be 4 pi r square S into 20 square divided by this entire thing, 4 pi r square S into 8,000. Do this, you will get this as 1 by 20. 4 pi r square S will cancel. 8,000 is 20 cube. 20 square, 20 cube. One of them will remain, so that's 20. That's the answer. I hope this is clear. These are the simple questions that you can get in JEE Mains or Advanced. Some of them are also taken or inspired from JEE Advanced, let me tell you. Let's do one last question for today. Very good question. Let's see how many of you are going to get this. What should be the extra work done to double the radius R of a soap bubble in air? So if you want to double the radius, okay, I don't know, both of them look like bubbles to me. Who is blowing whom, God knows. But if you want to double the radius, what is the work needs to be done? Come on, let's see how many of you are going to get this. Very interesting. Thank you, Aditya. Come on. Let's do this. Come on, come on, come on, come on, come on, come on, guys. Sneha wants to play with the bubble. I am guessing it is this bubble, not this bubble. Okay. Aditya, my Instagram handle is mentioned. You can check it out in the description box below. You can definitely ping me. Okay. Chalo, let's have a look. A lot of you are saying D. Some of you said C. Okay. So the correct answer is B, by the way. Okay. Now let me tell you why the correct answer is B and see where you guys got fooled. Guys. Okay. Let me just bring in those two bubbles first. This was a smaller bubble. This was the bigger bubble. Okay. So the initial radius was R, the final radius was 2R. Now think about it. Delta U will be the work done, and delta U, remember I told you it is S delta A. Now what is S? S is S. What is change in the area? It will be nothing but 4 pi R square. That's the sphere's area, correct? But that R is going to be 2R, so 4 pi 2R square minus original area was 4 pi R square. Now there is a small mistake in this. I'll tell you what that mistake is. Now this will be equal to S into 4 pi can be taken out common, and what will remain inside? It will become 2 square, which is nothing but 4, and minus just 1. So this will become 4 minus 1, which is 3. So it will become nothing but, oh, that R square is also there. Sorry. So this will become 4 pi R square into 3, which will become 12. So 12 pi R square into S. This is what one would get. Check this out. Everything has been done properly. But there is a catch. Guys, do not forget, every bubble has two surfaces. This is surface 1 and this is surface 2. How can you forget? Inside surface and outside surface. So there are two surfaces. So strictly speaking, there should be into 2, because each sphere's area, I should take it, one outside, one inside. Radius are the same. So into 2, because of which the correct answer is 24 pi R square S. This came in so many exams, BATES, CETs, AIEEEs, IIT, Harvard, so many times, and that's why this is very important question, because people forget that too. There are two surfaces. Okay, I hope this is clear. What a question this was. What a beautiful question. Interesting, very interesting. Now these are the stars of our previous sessions. Princey for last session, who have posted the answer, Saurav, then Ankit Kumar Singh, then Shabana Jafar, then Simran Mohapatra, and Shubdeep Singh. Very good. Congratulations. You are the stars because you are posting the answers. So all those people who will post the answers, doesn't matter whether it is correct or whether it is wrong. If you are posting the answers, you are the stars. So congratulations, guys. And I will be posting the answer of the previous session in the Telegram group below. So go ahead, join the Telegram group, and today's homework is this. Find the density of the liquid of the hemisphere if it is just being held only because of surface tension force. It's a very simple problem, but this question in modified way came in JEE Advanced, like a passage. So very important, because this will clear a lot of your concepts. So post the answer in the comment box below. After the session is over, the solutions will be uploaded only on the Telegram group. It's only going to be on the Telegram group. All right. Okay. So hope to see you all in the crash course as well. So the link is in the description box below. Go ahead, because you're going to get 120 live sessions, 20 series, test series, and unlimited doubt solving right from morning till the night, and lot of tips and tricks sessions. And lot of students are taking the benefit. Those of you who could not afford or probably did not get good coaching in the previous 2 years. So guys, this is the last chance. Come on, join in, because every Monday this crash course is starting for 12th and the repeater batch students, and the price is hardly 8,000 when you use the coupon code SHCC. So go ahead. I hope you have already subscribed today's you already liked today's session and you also subscribed to our channel, right? I hope you have done that. So bye bye minions. I'll be seeing you tomorrow at 7 p.m. for the second part of surface tension, where we are going to talk about, pressure inside the bubbles, curved surfaces, and then angle of contact and capillary effect, and so many amazing phenomena which are related to all these things. So see you again tomorrow at 7 p.m. This was Shreyas here, and keep smiling, keep rocking, keep solving, and stay motivated, guys. Bye bye. Take care.